Welcome Agent Spleen. Execute radial scan. Access granted. Today's mission. What is remediation? Why need remediation? Where to apply remediation? How to apply remediation? Propose remediation to be applied in Malaysia.
Remediation is where a lot of people fail because if they can't properly diagnose the problem, how could they write a prescription to solve the problem? So remediations fail every day, all over America, and sometimes they'll fail 2 or 3 times. Well, one thing our firm does is people pay for it once. That's it. We have never had a remediation failure in 26 years. Hell, I've done over $3 billion with the construction projects. But it has to do with methodology, it has to do with belt and suspenders, it has to do with building redundancies in your program and understanding those systems. I used to tear apart and put back together over 250 to 300 residential, commercial, and high-rise buildings a year. That gave me an incredible discipline of understanding of why buildings fail and how to fix them. In fact, our firm put 10-year labor material warranties on almost everything that we touched. Remediation is a unique animal, and people in the new construction don't understand it. And if you take new construction people or people that are just kind of blowing and going and put them in the restoration industry, you're going to have significant failures.
What is remediation? Remediation is moving leaked or spilled waste from a contaminated land/soil. The contamination spills include industrial chemical, hydrocarbon, asbestos, cadmium, etc. Why need remediation? To avoid human exposure. To maximize the land use. To preserve polluted land for better alternative. Where to apply remediation? Contaminated soil. Emergency spill of industrial chemicals. Closed municipal solid waste landfill. How to apply remediation? There are 4 technologies being used: A. Electrical resistance heating; B. Soil vapor extraction; C. Chemical oxidation; D. Excavation. Electrical resistance heating is an intensive in-situ environmental remediation method that uses the flow of alternating current electricity to heat soil and groundwater and evaporate contaminants.
Electrical resistance heating, or ERH, is a technology used to remediate soil contamination from spills of volatile chemicals. This animation describes how ERH remediation systems are designed and operated. The red mass represents subsurface soil contamination from a spill of trichloroethylene, or TCE. The mass was created by statistically modeling analytical data from over 200 subsurface soil samples. For a more detailed animation about the 3D modeling, please click on the link above. ERH remediation operates by transferring an electric current into the ground using conductive electrodes installed into the subsurface. The electrodes are shown in orange. The electric current is typically obtained from nearby power lines and modulated with an on-site transformer. Since soil does not conduct electricity very well, the electric energy is converted to heat, causing the soil temperature to increase. The soil temperature is monitored throughout the treatment zone using temperature monitoring probes, represented by the yellow lines. When the subsurface soils approach 180 degrees Fahrenheit, the TCE will begin to vaporize. The TCE vapor is removed from the subsurface using extraction wells connected to a high-powered vacuum. The vapor extraction piping and vacuum are shown in light blue, and the perforated screens of the wells are shown in dark blue. The TCE vapor is then filtered through tanks filled with activated carbon, shown in green, and clean air is discharged. To confirm that remediation goals are met, confirmatory soil samples are collected during the ERH operation. St. John Mittelhauser and Associates has met the remediation goals on over a dozen ERH projects and is dedicated to achieving the goals in the most cost-effective manner. On this project, by modeling the data in 3D, the size of the treatment area was significantly reduced, saving over $2 million in materials and operational costs.
Soil vapor extraction is a physical treatment process for in situ remediation of volatile contaminants in bad zone soils.
Ecologia's soil vapor extraction technology is a well-proven and relatively simple approach to contamination in the unsaturated zone, that is, the soil above the water table. We literally suck volatile contaminants such as petrol and solvents out of the soil. Once the contaminants are above ground, we separate the extracted vapor from the liquids. Naturally, we want to protect the air that we breathe as well as the ground beneath our feet. So the extracted vapors are cleaned before discharge by passing through a granular activated carbon filter. A single vacuum blower can provide suction to 1, 10, or even 50 extraction wells.
In situ chemical oxidation involves the direct mixing of reactive chemical oxidants into the groundwater and soil in order to quickly eliminate contaminants within the subsurface.
Ecologia can employ specialized in situ oxidation technology, which can be used for contamination both above and below the water table. When applied correctly, this can be effective against most types of organic contaminant. Injection well design is crucial and is carefully specified for each project. The chemicals we use are powerful, yet they leave no significant environmental impact as they break down quickly into harmless soil components. Specialized knowledge is required to inject these chemicals safely. Ecologia has developed a highly effective and safe in-well mixing method. Contaminants are broken down rapidly on contact. Several injections may be required for some sites.
Excavation processes can be as simple as hauling the contaminated soil to a regulated landfill, but can also involve aerating the excavated material in the case of volatile organic compounds.
This animation shows how a site contaminated with chromium from plating operations can be remediated using soil excavations. The transparent yellow mass represents soils with a low level of chromium contamination, modeled from soil sample data. The red mass represents soils with a high level of chromium contamination. These soils are deemed hazardous waste for their potential to leak toxic chromium into the groundwater and cannot be left in place. These soils were excavated, chemically stabilized on-site, and transported off-site for disposal. One of the excavations is pictured above. In order to address the low-level contamination still present, an asphalt cap 3 inches thick was installed. This cap, referred to as an engineered barrier, will prevent any possible human exposure to the contamination. The asphalt cap is pictured above.
Potential application of remediation in Malaysia were listed.
Thank you.